So it's getting recorded.
Yeah.
Yeah. So we can start with our first problem. They are giving us the minimum index sum of two lists. So, I mean, there are two persons who are supposed to choose a restaurant for a dinner, and they both have a list of favorite restaurants represented by the strings. And we need to find the common interest with the least index sum. So, and if there is a tie in your answer, you output all of them, or you could assume there always exists an answer. So if we look at the first example, so here Shogun, and again the same thing you'll find common here, and index of this is 0 and index of this is, what do you say, 1 0 1 1 2 3, so 3, and this is the only thing which is common, I think, in these two. So they are not talking of least index over here. And uh, next thing, if we look here in this first, here you can see the index of Shogun is 0, and in this here it's 1. So 0 plus 1 is 1, and which is the least index, right? And if you look KFC here you'll have 0, but here you'll have 0 1 2 3 4. So 4. So that's why we are using this one as the output. And regarding the constraints, is like you won't find any duplicates in both the list, and index will start from 0 to length of list minus 1, and length of strings in both lists will be in the range of 1 to 30, and they'll be in range of 1 to 2k. Yeah. So how do you proceed? Like,
So there are no any constraints, like if you want to clarify on the requirements, it is pretty straightforward, right? You have just two lists, and they are all strings. That's
yeah,
all, right? There won't be anything very different we need to actually worry about, correct?
exactly. Yeah,
Or do anyone think about it? Only thing, if one of the list is empty, that might be the case. So what
could
do
be.
you
Yeah.
do? Yeah.
Mhm.
And they are saying something about if there is a tie.
Then you have to output all those
Yeah, so tie means like you have a matching uh,
index sum.
index of all those restaurant names, right?
Yeah,
Okay, if they are same, then we just uh, output all of those in any
yeah,
order.
yeah.
You can take the example of like A, B, C, D, D, C, B, A.
So Santosh, I mean, the constraint says that, I mean, they must have at least one restaurant each, right?
Or it says that the answer will always exist, right? Something like
Yeah,
that.
1 to
Okay.
1000 it shows.
Hmm.
Yeah, it won't be empty.
Okay.
Mhm.
Yeah. So I was just thinking loud, so yeah, that is the right word.
Okay.
Yeah. Drawing, yeah. So because that is what we have to do in the interview, right? To really clarify the requirements before going in.
True.
So yeah. So that is one. And I think if it is very straightforward, then yeah, I think someone was suggesting some input, right?
Yeah.
I was saying that was of that case when there are more than one answer. So you can take the example like A, B, C, D, and in another
Yeah.
A, B, C, D, and D, C, B, A. So this will output A, B, C, D itself.
Yeah. So, but this is 0.
So you are saying A, B, C, D.
Yes.
These are strings. These are 4 strings, and B, C, D, D, C, B, A. They are also strings.
Yeah. There are two different arrays. There are two different vectors we have been given, and in this case, the answer would be A, B, C, D itself.
Yeah, because all of them, if you add, you are going to get
Yes.
the same number. Yeah, that makes sense.
Yes.
Yeah.
Because all the sum will be, I think, same. Because something is occurring first, that is occurring at last also.
Yeah.
So the
So
index list will be 3.
Yeah.
Index sum will be 4. Okay.
So if somebody wants to share the code.
Yeah, but what approach we would like to discuss first?
Yeah, sure.
Can I share my approach?
So what is the brute force? So brute force would be just going through both the least in n square. Maybe if both of them are n, assuming both of the lengths are in n, right?
Hmm.
And just keep on going through two loops and keep on finding whichever is the least index.
Yes, n into
Correct.
m.
Yeah, and add it to
And
some array or something like that.
yeah. And better to start with the shorter list because those many number of elements you can have common at maximum.
Correct.
Yeah, that could be.
But will it matter for a brute force if you start with
I
shorter? I
mean,
think.
slight optimization, nothing as such like.
Okay. Okay, makes
Mhm.
sense.
Yeah.
And if that is not the case, if we want to optimize further on the time complexity, then we
Yeah.
need to use some data structures, right?
Exactly.
Yes,
And what is the best data structure you think about it, Gaurav?
like I used this um, unordered map thing.
Okay.
Yes,
Hash map, right?
yes, yes,
Yeah.
yes.
Mhm. And in the
Like,
hash map, you are actually storing everything, or you are
can I
storing.
share my approach by
Okay, go
using?
ahead. Yeah,
Yes,
maybe you could actually do it on a whiteboard also before if
yeah,
you
yeah.
want to. Yeah.
Is it visible?
Yes. Yes.
Yeah. So basically, what I've done, I took one map, and in this I stored each and every element of this list one. Okay.
Mm-hmm.
So like if I take the example A, B, C, D. Okay, and with it I am also storing its value of index like
Okay.
0, 1, 2, and 3. Okay,
Mm-hmm.
so now after this I take I yeah 1 second. Yeah, after this what I did, like I took uh, another unordered map,
Mm-hmm.
and before what I'm doing, I'll run a loop. I'll run a loop and I'll iterate it over list two. So if that element is already present in list one, if
Mm-hmm.
that is present in list one, I'll take the value of that and add the value of index of L2, and then I'll just insert that element into it with the updated index. Like for this uh, D C B A.
Mm-hmm.
Okay, so its value was 0,
Mm-hmm.
0, 1, 2, 3. So when I'll check if D is present in list one, I see its value, it's there, and its value is 3. So
Mm-hmm.
what I'll do, I'll just take this value 3 and take this value 0. I'll add it I'll add it up here, and this value will be 3. Then I'll go to C. I check if it is in this array, it's there. So I take this value 2 and take this value 1. I put it over here. So it'll be 3. Same will be the case with B and A. They all will come 3 and 3. And then after this, I'll run a loop. I'll iterate over this whole
Second
uh,
map, right? Yeah.
yeah,
Mm-hmm.
second map,
Mm-hmm.
and just take the minimum out of them. So
Okay.
whatever will be minimum, I'll return the answer. On that. I'll return that.
Yeah, I think this makes sense. Yeah.
No.
So any questions, anyone on this?
No, again, same thing. That shorter one, what I was saying, like if you start with shorter one checking, you'll have to traverse less length of the list because I mean, list. I mean, only those many amount. The length of the list will be the number of elements that would be common in the larger one, right?
Yes.
Right. Yeah.
Yes, that small one.
Yeah, but anyone wants any clarifications on this or any optimizations we think of?
So Gaurav, are you using two unordered maps?
Yeah, I'm using two unordered maps.
I think it will be done by using one only while traversing again. So we can take the minimum.
Yes,
I
we
think-
do it one by one
I've
map.
used-
I've done by one map.
Yeah.
Okay, so you are saying that we can do an optimization on the space, right?
Yeah.
Okay.
Yes.
So his approach is with two maps. So let us have a look at it first. Then we'll go for
Yeah,
other.
one second. I did this same before this approach. What problem was coming for me? Let me show you that.
Yeah.
Yeah. So what kind of problem was coming? Let's say if I have this this E therefore for this instance, I did this same like 3, and for this, let me do this 3, C, E, and D. Let me put one more element in the first list. In the second list, there are only D, C, B, A. In the first list, there is A, B, C, E, D. Okay. So the answer of this would also be this 3. Same would be the case of this for this. So this problem was coming for me, like when I checked the minimum answer of all of them, the E would also come up as my answer. But E was not there. In this list.
Oh, you are saying if you had E,
Yeah.
which was at index 3, then
Yeah.
that also will be a part of.
Yes.
So then why not we take the case of Shashank, the way he was saying, use the smallest one as the least one, something like that. Yeah, but that is fine what you did. Yeah, so you
Yeah.
had a valid issue about that. So we can
Yeah,
go ahead
But
with the code.
we don't need that thing also, like smaller list. I just took one first list without checking the size, and then I just used one map, and in the second loop I was running the second list, checking the sum, and then checking the minimum out of it. Like, I think we can go first with this code,
Yeah,
with
please.
his code.
Let's
Yeah,
go with that, and then
I did that
we'll
thing,
go that.
but once this was the case where I stuck.
No problem. So we can take this test case, and then we can actually run through that also with other
Yes.
code. Yeah, no problem. Good.
Yes, sir. I'm done.
Yeah. Code you want to share?
You just
Okay.
share the core. Yeah, walk through it quickly. Yeah, that's it.
Mm. Yeah. I took this unordered map, one word unordered map. I inserted three elements, and then basically I took minimum for this like int max thing. Instead of that, what I did, I took maximum of list 1 size or list 2 size into 2. I hope you got why I this did this thing into
Yeah,
2.
so you're using some max value. Yeah, that's fine.
Yeah. So then I took this vector v. Then I took this another map umap, and after this I start iterating over this second list 2. If that element is present in that map, I'll update the value of it. I'll update the value of it. I'll make pair list of two, that element, that key, and map a value of that element from this previous map plus one, plus index. And if that map value, if that map value is less than minimum, I'll update the minimum of that. So in the end, I ran another loop over this over this second map. Uh, if the value of if the value of our element is equal to minimum, I'll push back, insert that value into it, and at the end, I just return the value.
Yeah, I think it's perfect that way. So
Yeah.
yeah, that should be fine. Yeah, thank you, Karun.
Yeah.
So anyone wants to share any optimized one? I think Sonal said, right?
Sonal,
Yeah.
Sonal, yeah.
Yeah, 1 minute.
Okay. It's 599.
Hello. So, okay, what I did is like first I started with the list one and I stored a map for the list one here.
Okay.
Okay, so like let's see for the like I'll take the example two for better understanding. So suppose for S is at 0, like Shogun is at 0, then uh, TE will be at 1, Burger King will be at 2, and KFC will be at 3. So I'll create the map like this for the list one. Now I started with my list two, iterating over the list two. I'm just finding in my map if I have my list two is like first element is KFC. So I'll just check the my key if it exists in my map. If it is existing, so this is what it will do is it will count the number of keys present in the map. So yes, I have found KFC. Then I just add the list to index that was 3 plus the index of in my in my map I searched it was 3, and then the current element of the list 2 was at index 0. So this will become 3 plus 0, that will be 3. And I have like taken one more integer maximum element which I've initialized to int max. For that, I'm just checking if my sum is less, sum which I've calculated here is less than the max one, then I'll just push back that element because I found something. And before that, I cleared my vector answer to like if because this loop will run again and again. If I find something more less than that, so I just remove the previous element and push back my new element which has the least sum. And if I find the same sum and max, if they become same, I'm just pushing back that again, and like I'm setting my sum to max. Is it clear,
Yeah.
or I'm lost
No,
somewhere?
no.
Yes, ma'am.
It is
Yes, ma'am.
clear. Yeah.
So here anyway, after these two are the just conditions we need, and we have to set, because we have find minimum sum. If I'm in this or in this loop, I'm just setting that minimum sum to max, and again the loop will run. So I don't think it will matter if I'll take list 2 first or list 1 first. It will work either way.
So every time that max will get updated, right? I mean, with the current, like,
Yeah, max will be updated if you find the sum which is less than like your previous sum, so my max gets updated.
Yeah. No, so that's good, but only Shashank's point was, if least one was of 5 elements, least two was of 5 elements, and least one was of about 10,000 elements. So you are creating
Yeah,
a map of a larger one, right? So that is only
exactly.
a small concern what you had, but that is fine actually. It should not be a big deal though.
Yeah,
So
Yeah,
definitely.
I think in this inputs are like 1,000, not
yeah,
much.
1,000, yeah. So not much, therefore it's fine. Yeah, but that is also a valid point. So we can always have some minor, optimizations.
Okay.
But this is good. Yeah, what you say is good.
Okay.
Yeah. So anyone has any questions on this?
So just one thing, I just joined. I don't know
Okay.
whether you discussed. So if you have a Shogun appearance, right, more than twice, like here there is in the input example two, Shogun is appearing once, and then KFC is appearing once. And what if Shogun appears twice in the both the cases? Like
No
if you
duplicates not allowed.
duplicate not allowed, is it? Okay.
Yeah.
Yeah, that is
Oh,
what the
okay.
constraint says. Yeah, no
Okay,
duplicate.
okay. Yeah, then it's fine. Okay. Sorry, I did not read. I just joined. I just read this.
That's
Okay.
okay, no problem.
That's
Yeah,
okay.
but it's a good point.
Somebody's asking to repeat the second loop, I think, in chat. ST, yeah.
Okay, what in the second loop, what I'm doing is I'm just finding, like, suppose now in the second list, first element is KFC. So I'm just finding if in my map I have KFC key or not. If I find that key, what I just do is like take that value of the key and add with my current index of the list 2. So here it is 3, it was 3 and this was 0. So 3 plus 0 is 3. So my sum becomes 3. Now when I compare with my max integer, so my sum is less than that. So I just push it into my vector answer. And then later, after coming out of this condition, I'm just updating my max element. Again, like when this loop will run, now I'm on Shogun. I find Shogun in my map, which is with whose value is 0, and so I just add that. That will become 0 plus 1 equal to 1. So my sum is now 1. So in the last loop, my max was updated to 3, and now my sum is more or less. My sum is more or less. So what I did is I removed my previous element and added back Shogun in that here. After that, this loop is not obviously will not work for this, and I'm updating my max.
Yeah.
So this loop will run only when my max and sum become same. That means my previous sum was also same, and what I've calculated now in the
That
next
is
iteration of the loop, that also becomes same. In that case, I need to have both the elements in the vector.
Yeah,
That's
that's
my
a
answer.
special case that they were saying, right?
Yeah.
tie case.
Yeah.
So that tie case will be handled by this.
Right.
And I'm removing, clearing my vector here because I found my sum more or less than the previous one. So I just need to remove that element and push the next one.
Yeah. So you found a better answer. So you'll always do that. Clear it.
Yeah.
Yeah. I think that's good. Yeah.
You can remove line number 17 and line number 19.
Or you want to say, you are saying that you can exchange both of them, 19
Oh, just
and,
just delete
No,
these
yeah, I
lines
got it. I think he's saying,
and 19.
no, I think I need to have, right?
You don't need the 19.
How will you take care of tie then?
No, yeah, I need to have that.
okay.
I need to have that, right?
Oh, if
Yeah.
it's a less, then you clear that and push the element. So remove the 17 and 19 both.
Yeah, he's saying, you don't need the 9. Yeah, that might be an optimizable to done through, like, if you remove 19 and 20.
No,
Just
19 and 17.
19 and
Yeah,
17.
he's saying that if you're anyway you're clearing, right? If it is less than clearing,
Yeah.
so clear and push. So when you are equal, you're pushing. So he's saying remove this condition on the 19. So and just keep pushing into answer. and remove
But
17
they are
as well.
two different cases. No?
So for 17 you have to push, like 15 you have to push some less than equal to max, is it?
No, but 15 you clear on 15, after 15 you clear your list, right? And then you are pushing.
Yes, yes, yes.
So if you remove the line number 17
Okay, and
and remove line number 18 where you are checking that sum is equal to max.
so that is the special case. I don't need to run it every time, right?
No,
Yeah,
if
yeah, that's correct.
in 15
That's
if you
correct.
make less than equal to,
Okay.
No, it won't work.
I don't
Because
Because you
then
have
it
to
will
find
clear
one,
the
at least
vector.
one.
Got
Yeah.
it, got it.
Yeah,
It
you
No,
will
have
I
to
think
clear
find.
it's
the
fine.
vector
This is fine.
otherwise.
Yeah, this is fine.
Yeah, no problem. I think
Sorry
yeah,
about that.
no issue. So looking at the time constraint for the first problem, like, can we move to the second one now?
Yeah. So one thing I have to
yeah,
say.
exactly.
Yeah, okay, yeah.
So I also followed the same rule, but instead of using ans.clear, what I did was I initialized ans to an empty vector every time,
Oh yeah. You
because
can
I
do
think
that
this
too.
clear function takes off and time.
Mhm.
So just initializing to an empty vector would be a constant thing.
No, but that will create a new memory all the time, right?
New memory, but that memory would be empty initially.
Okay, so there are many optimizations we
Yeah,
can do,
that's the
but that is
implementation.
I think
that's okay,
the
right?
clear will only like remove the previous value, right? We won't have like so many elements in that vector already.
Yeah, we can actually have a lot many things about those implementation things.
Small stuff, yeah. But the
Right, yeah,
crux,
but
like
yeah, the major thing is actually this is okay, right? So that should not be a
Yeah,
problem.
I think this is fine. We should
Yeah,
continue.
we should continue with the second one.
Maybe others, if you are not talking, can you mute? There is a lot of background noise.
so let's I think some distant barcode is audible, right? Yeah. So am I audible, right?
Yeah.
So yeah, distant barcodes are given. So there is a warehouse in which row of barcodes is given, where your ith bar code is the barcodes of I. You need to rearrange the barcode so that no two adjacent barcodes are equal, and you may return any answer. And it is guaranteed that you'll have an answer. So here, like one, if alternately they have arranged, and none of them should be adjacent. One shouldn't be a duplicate. So same thing you can see over, and it could be any possible answer. And your constraint are like, yeah. So how do you proceed here?
So first of all, the barcodes will always be integers.
Yeah. Why would, I mean, apart from that, what it can have?
No, I thought like a barcode maybe something like a string also, right? So
Oh, yeah. But I think it represents the length or what? No, yeah, it can be string.
no, they are not saying anything like that. So looking at the input of this function signature, it is integer. But if someone talks about it like barcodes, and then you always think of something like a string or maybe 1010, something like that, a digital string.
Binary
Something.
code.
Yeah, binary code.
Okay.
So when I saw integer, I was slightly, confused
Yeah.
how it can come as an integer. So things to clarify will be on these inputs.
They might have encoded binary to integer. That could be.
Right, yeah. And I don't think there are any more constraints to worry about here in this case.
Yeah, I don't think so.
Yeah. Also, it says that we'll always have a proper answer for this. I mean,
your answer
we won't
will.
have an array if it's all the ones and.
Mm-hmm.
No, it's not possible to have all ones, right?
Right.
Yeah.
So we don't have to worry about that case.
Yeah, sure.
Right. Yeah. So on a high level, what will be a brute force way of doing this?
Checking all the permutations, I guess.
Yeah, but permutation, how will you take care of that adjacent shouldn't? Yeah, could be.
Yeah, that is what I'm saying. Like you have to check, make the all permutations of, like you have your what 6 numbers in the first case, right? 6 numbers in the first case, and 3, 1, 3, 3 are 2. So what you will do in the first index where itself you can put one or 2. Okay. Then in the next
Yeah.
index you can put only 1.
Okay.
So in the third index, you can put 2, but this will work in this case only. Like, what if we have, more than two
Different
distinct numbers? Then you'll have the case. Then you'll have to check, have the, all the different uh, arrays you can have with those numbers, and then out of them, if all those are any of that array which satisfies that condition, this condition, we'll have that as answer.
Yeah, or you can place like first 1, 1, 1 you can place. So 3 elements, so 4 gaps it will be generated. And out of 4, just place 4C3 into 3 factorial. That could also be one, right?
Yeah, that would work in this. That's what I'm saying. That would work in this case when you have two different
Categories.
integers.
Yeah.
What if we have 3 different integers?
There it won't.
Yeah.
So
Implementing permutations, how was Gaurav saying? Like you have
yes, sir.
a loops, and then you need some other also, right? Help or something like a data structure or map, something like that.
So actually, this is the brute force, which I think could have been, but I don't really think so that would be implemented by me.
Okay.
So the brute force, why don't we like have 2 pointers looking at this sequence, right? So first check 0th and the first index, right? And then if it is same, then keep on moving the other pointer till you don't find the same number. And if you find the same number, then insert between those two, the 0th and the first, and then shift the pointer to the next one. So and then keep continuing. That way you are also doing the brute force, right?
So what do you think implementing this will be terrible? Like, I mean,
yeah.
If you have 3, 4 categories of numbers, then like 1, 1, 2, 2, 3, 3, 4.
Excuse me. Actually, what he is saying, that would be the case itself, but it could be implemented in a better way. But that's the only logic behind this answer. That would be the
That's
logic.
True.
Like what he is doing, he is doing would take more time. Just in order to reduce that time, we will use unordered map, or unordered map and priority queue thing. Like we would do this same thing,
Yeah, logic will be same here, but implementing that logic, I mean, taking care of many pointers that I was saying.
2 pointers you keep. Anyway, this is just a brute force. Obviously, there's a option we are discussing, but you will keep 2 pointers anyway, right? Can I share whiteboard? If you don't.
Sure.
Okay, I'm not good at writing, so I'll try to write. So you have 1, 1, 1, 2, 2. Okay, we'll take this one, right? So you have first pointer here, and next check if it is same. This is P and this is Q. So you, if it is same, then move this Q until you find this one, right? So you found this one. So you just, you need to do like insert here. and then you move P. So obviously this is like a lot of iteration. Now the P will point to this index, and then it will compare whether these two. Next, the Q will move to this index, P1 and Q1. So then you will compare these two. Obviously they're same. So then you will keep moving the Q, and Q will move to here. And you find this is the two which is not same. Then you insert in between this one, and then the P will move to this here. So obviously this is a lot longer and lot this thing, but this is the initial thinking which I get by
No,
seeing
but
this one.
if you're saying two pointers, it means it's very optimum solution, right? You will be doing it O of n.
But
Yeah,
still, I
often.
like.
But brute
Let's
force
say-
would be like you actually generate all permutations of this
Okay.
list, and then you just compare which one is the valid one, and whatever
Yeah.
is valid you return. So, but actually
Okay.
coming with that implementation is very difficult. That is what I was when I was thinking about it. It's not so easy to come up with that.
Oh, this
So
one
if
coming with this implementation.
this is yeah, this is optimized version, but
Okay.
coming up with a brute force is slightly difficult. That is what my thoughts are. Maybe I'm wrong.
Okay.
Yeah, I think the counter example of that not gonna work because let's say you have like 1 2 1 2 and R3 on the back, right? So now you keep alternate between 1 2 1 2. So now the leftover is 3, right? You have like, let's see, suppose if you write down you have 1 2 1 2 and 3 3 3, yeah, like that, right? So if you find that you alternate between 1 2 1 2 and now you left over with 3,
Yeah.
then
So,
you have no way to do it.
yeah.
Instead, you
Yeah,
have to put 3 first.
Yeah, other thing I was thinking was like you see these same, right? You start taking from here, like for example, you see these one same. Yeah, you can start from end. I'm not sure.
Well, because you don't know, at the end it's gonna be the most frequent number.
Yeah.
Right. You have to find it.
Yeah, but yeah, I think what Leon was saying is also one thing to think about it. But I think this is a more optimized solution. Yeah, it's a good solution though, but it will be the optimized one, and it may be possible to implement that also the way you are saying.
But if we have lot number of categories, then again I think this.
No, I think what we could do is sort it in a reverse order, right? And you start from the beginning. So at the beginning you'll have the maximum values, right? The values which are at the high. So that way it should be possible to do. Yeah.
But may not be in the
Actually,
sequence.
sir, actually, just one thing, like when you say that we have to sort it in the reverse order, we have to sort it in the reverse order, but on the basis of their frequency. Like
on the frequency, you need to sort on the frequency there.
Yeah, on the basis of frequency. Like if you take the example second, had you been sorted that array on normal basis, it would be 3 3 2 2 and 4 1, and at the end it would generate the wrong answer.
What if we like store the frequency of elements in a map?
Yes, exactly.
And then run that map till all the frequencies become 0? Like,
yeah, I think that is also a good one.
So I just by looking at the question, like simply it came to my mind that only.
Okay. So if anyone has any questions, I think there are many people on the chat also.
Maybe so you want to explain on whiteboard? I know I understand for this benefit as well. Maybe.
Sure. I think who wanted to go ahead? It was Sonal or Gaurav?
The last one, Sonal, I think.
Okay.
So actually, I haven't implemented it. It's just like that logic came into my mind, so I can.
Go ahead, because even I did not implement the first one. I just went with the explanation, and then Leon pointed out the flaw, right? So it is fine.
Okay. 1 minute. So are you able to see? Are you able to see? Like,
Yes,
Yeah,
yes.
yeah.
Yeah.
okay, so suppose I was just thinking, okay, it is sorted. I mean, it's not necessary we take it sorted. So I'm just keeping the frequency. So one is occurring 3 times, two is occurring like 3 times, and 3 is again occurring 3 times. So this will be kind of the map which I'll create. Now I'll just loop over my map, and I'll just first print one, like I'll push it into my vector array, and then I'll keep deducting the frequencies. I mean, this will become 2. Then I'll pick up the next element, and then this will also become 2, and then I'll pick this, and this will frequency is keeping reducing. So basically I'll just push one by one unless all the frequencies become 0. Like, I've just thought this way. So this will be like again 1 2 and 3, and 1 1 2 and 3.
Yeah, it
In
will work.
case if the remainings are like, for example, the 2 is 4 times, now
So
there will
actually
be,
it is given, right, that the answer is possible. I mean, like if 2 is 4 times, suppose, so at the end, what will happen is like all these will become 0. This will be like something 1 will left, and this will be 0. So I'll just keep iterating over the map again unless all the elements become 0, something like that.
okay,
Excuse me,
but
ma'am.
for example, now if we consider 2 5
So
times,
this
now
will
the 2 will appear twice in the end. So will it be considered as invalid?
so if it is 5 times, so if suppose 2 was 4 times, so 1 2 3 1 2 3 1 2 3, and last 2 will come. But if it is 5 times, as you are saying, but that answer is not possible, right? Because they are saying that answer is possible, and this is obviously invalid. But that kind of input we don't have, right?
Okay, so let's say 1 is 5 times
Okay.
and 2 is 2 times
Okay.
and 3 is 1 times
Okay.
and 4 is 1 times.
Okay, 4 is also 1 time. Okay, so this will be like 1 2 3 and 4. After this will become 4, this will become 1, this will become 0, this will become 0. So now if you see, it will be like 1 and 2, this will be 3, this will be 0, and those will not loop over. So I think then answer is not possible, or is it? Like, I'm not sure.
It is. It is like you should
It is
take one
possible. So,
first, then
yeah,
2.
you
Yeah.
can put 1 2 1 2
Oh yeah, I
and
think then
then
it will
1
not
3
work.
1 4.
Yeah, got it. It can come
I
here.
think instead
You
of
have to
looping
start it, I think.
entire all the keys, maybe there should be some logic to control the loop.
Yeah.
Yeah, you need to
Yeah, something like that. I
you need to
need to
sort.
think.
Yeah, you need to sort the values, key values also.
Okay.
No problem.
Yeah,
Yeah,
like
that's a good
I was just
explanation though. Yeah.
thinking. Well, okay.
Yeah,
Right. So
because I
good
think with
start.
the
Good
map
start.
it will work, but we'll need more some more things to do.
Yeah, it
But
seems
there
like
might be something other to do also.
we
Yeah.
need to keep frequencies, but how we'll use to like populate our answer vector, that we have to see.
Right. So there might be some
Uh,
more optimized way of doing it also. So let's see what
Excuse
others
me,
are
sir.
about.
So if we consider, for example, like reducing the more frequencies first and then draining the remaining one, like for example, in the same example, if we try to reduce the frequencies that are like, for example, the 5 is the maximum time it is coming. So we try to reduce that one first and then we can drain the rest of them until it comes on the same order, something. It is just a thought, but
Yeah. Do you want to explain that on the whiteboard? Okay, I think we
okay,
lost.
wait. Let me
Yeah.
open up.
Okay, no problem.
Okay, are you able to see my screen?
Yes, yes.
Okay. So, for example, 1 is occurring 5 times, 2 is occurring 3 times, then 3 is occurring only once, 4 is occurring only once. Now we have that 5 and 3 are most of the time it is occurring. Okay, so we are assuming that the whatever the values which we have is stored and sorted in the reverse order. So for example, now we have to reduce that value. So what we can do is we can iterate them first until the all of them comes on the same order. Like for example 1, then we can move to next, and then we can check whether the first value, for example, if we reduce this by 1, now it is 4. Now we try to reduce this, now it is 2. Then we can check how many times it is being reduced. Like for example, this is 4, now this is 2. Now this one we cannot use because it is not on the same order. So what we can do is we can skip them, we can again come on this, and we can reduce this again until they come on the same order. So now if the this value becomes on same order, then we can use the same. This is just a thought. I'm not sure, like for example, how we can iterate them, because I need to reduce them in different order. Like for example, reducing 5, 3, and then stopping them again, and then again come to 5 and 3.
Okay. So what data structure
Yeah, obviously
you
it
are
would be
planning to
map
use?
only. Yeah, it would be map only.
Okay. It's almost similar to Sonal, but you are trying to take care of this situation, right?
Yeah.
Okay.
I think in this one, like we need to keep track of the larger two frequencies, something like that.
Yeah, something like we need to make sure that the larger were at least come to the same position where all of them are. Like for example, if everyone is on one position, then it is okay, we can just write it down directly. But if someone is already on the second position, like for example in this case, 1 is occurring twice, 2 is occurring once, 3 is occurring once, 4 is occurring once. Now what we can do is we can reduce 1. So we have reduced this by 1. Now the value is only 1. Now it occurred on the same time. Now what we can do is we can print them. Like for example 2, 3, 4, and then 5. Now in same scenario, for example this same scenario, here we consider 3. Now what happens is when we reduce this, it will get 2. Now if we try to print that, so now we will print 2. But there is a catch over here. Like for example, it will become 0. Now all of them are not on the same order. So what we can do is we can again go back to the same position, reduce this by 1. Now all of them are on the same position. So it will print 1, 2, then 1, and then 3, 4, 5.
So you always want to take care, or maybe store somewhere the highest two frequencies always, right?
Yeah, yeah.
Okay. So you can use some other data structure to do that instead of
Yes,
map.
sir. Actually, that's the thing that I've used. For this, we can use priority queue.
Okay.
Okay.
So how do
I'll
you use a
stop my
priority
screen.
queue?
So, can I show you my
Yeah,
screen?
thank you, Vignesh.
Yeah, I have stopped that
Yeah, no
screen
problem.
share.
Sure. Thank you. Yeah, go ahead. Yeah. Or
Yes.
anyone has any questions on the previous one? What? Okay, I think, yeah, go ahead. Go ahead.
Mm, yes, sir. So,
What I was thinking that, that if we count the frequencies and then allocate the output array of the size of the barcode, and now based on the highest frequency, just put the highest frequency by putting the hole, right?
Okay.
And that will go up to fill up to the half of the barcode length.
Okay, so you take the highest one first, and then you first fill in
Yeah,
all the.
hash,
Okay.
and then next hash, like that, and put the keep the hole in the output array. So you start with put the first value at 0, then 2, then 4, and go up to the barcode's half, right? And now start filling these gaps.
Okay. So you're
In
saying
that
you
case, okay.
So you would like
I'm
to
just
avoid
thinking
even the
loud, not
priority
sure. I
queue.
mean, is there any whether that algorithm is,
Yeah, I think
correct
so.
solution or not?
Yeah, because you will be avoiding the way Gaurav is saying about a priority queue. You will be avoiding that also, right? So because you already have a frequency map, or maybe
Yeah.
some frequency vector, and just use that. Always putting it in alternate positions.
Yes.
Yeah, that
From
might be a
the
way.
hashed one.
Right. That may be the most optimized version also. Yeah.
yes, sir.
Yeah.
I mean,
Yeah,
looks like though not implemented, so not sure is there any
Should be, yeah.
catch
It
or
should be
yeah,
possible.
edge
It
actually,
case.
looks like,
I
yeah.
did
Yeah.
the same. Yes,
I'm
sir.
sorry?
So, yes, sir. I said that I did this. I have done the same.
Oh, cool.
Yes, sir. So basically, what I did, I took an unordered map. I inserted. I traversed all the elements from this and inserted them, and got a count of their frequency from this, and then in the priority, I took one priority queue. What I did, I inserted all the elements from this unordered map, and because priority queue keeps all the elements like in a sorted way, so that's why I've done that. So after this, what I've done, like yeah, so I took the first element from priority queue, okay, and inserted that element into one array, into one vector which I took, and inserted that element into this, and I reduced the frequency of it, reduce the frequency of it by 1, and then after that I check whether my queue is empty or not. If it is empty, I'll just break away from this loop and answer return my answer. And then what I'm doing, I'm taking at the same time I'm also taking k1 and v1, uh, because for now we have wait,
Okay.
yes,
So,
yes, yes,
so
yes.
you are taking the next element based on the
Yes, yes, yes,
frequency.
yes, yes. It's because I have already popped out the very
Then
first element. Okay.
pushing.
So I have done the same in this. I've taken this next element and I've pushed it back in that array. And now I check whether my k of this element, previous element, the foremost element, which has been already ejected from this priority queue. I check whether k is still greater than 0, If it is still greater than 0, I insert that element back to it, because I've just reduced its frequency. I've not completely used that element. I insert it back. I do the same with this. So yeah.
Yeah, this
At
is
the
exactly what I was thinking, but I was thinking without priority queue.
Yep. Yes, sir.
Yes.
Yes, sir.
Sorry. Yeah. Thanks.
Yeah, looks perfect. Yeah.
Yeah.
But only thing what Praveen was saying, a slightly different point on that, maybe a slight variation is, you avoid using a priority queue. That
Yeah,
can be done.
but Santosh, he's doing the exactly same thing using the
Correct.
priority queue, and I was just feeling that, allocating the output array and filling it up front.
Right. I think that is a optimized version of doing it, because you'll avoid using the more space, right? So you are avoiding using a priority queue.
Yeah, the runtime will be
Can you
better than
explain a
this.
bit? Can you explain a bit how would we go around doing this without priority queue?
So let me actually share my screen. Though I have not implemented that was just a thought, and you guys can actually correct me if I'm wrong. Is there any concern in that?
One optimization in the previous one, like Gaurav, you used map initially. What if like I create the pair and you like directly insert in my priority queue? Will that work?
I thought of that, but the main problem would be just focus one thing. Like I have reversed the order. When I traversed from this barcode. I inserted it in a way. Let me tell you. I inserted it in K, comma V. K would be the value, and V would be the frequency. But then when I insert it, when I'm inserting these elements into this priority queue, I'm reversing the order. I am basically taking the key, this key
As a
element,
frequency, yeah.
frequency, yes.
Yeah. To your answer, Sonal,
Keep them,
that's not
sorry.
possible. That what the optimization, what you're thinking, that because we actually need the key
Yeah, we need the frequency.
to set the frequency.
Okay, got it. Okay,
Yeah.
I got
And
it.
it's more easier to do this way, because or else you'll have to always pop up the priority queue, change it again, push in, So this is a
Yeah,
very
otherwise if
easier way
we
of
do,
doing it.
which I was thinking, in that case we can't have that unique key, right? It will create problem.
Yes,
I got it.
because of this frequency, it's every time getting updated, and it every time take the most frequent element to its foremost
Yeah.
space.
Very perfect.
Okay.
Yeah. Thank you, Gaurav.
In this implementation, why do we need to pop the queue twice in the loop?
Because in priority queue you can only use pop the element. You can't traverse it through the priority queue. You can use the foremost element only. But what if we want, like in this case, we want the second most frequent element? So for that you need to first pop out the first element, first this element. Because of that, the second most frequent element would come to the first. Then you can use that
Okay,
element.
yeah, I
Otherwise,
understand it now. Yeah,
yeah.
thank you.
You guys see my screen?
Yeah,
Yes,
Praveen,
sir.
yeah.
Yes, I was
Yeah.
thinking like that. So let's say we do have input 1, 1, 1, 1, 2, 2, 3, 3. Let's take this example. So 1 is 4, 2 is 2, and 3 is 2 also, right? So with that, so we know that total number of element in the output array will be exactly same as the total number of element in the input, right? So just allocate that output space of the 6 element. Okay. And then start with the hash frequency and push into the output. Just skip 1. So 1, 2, 3, 1, 2, 3. So there should be 2 more, right? Total 8. So now I'm done with this part, and now pick the next hash and pushing it from there. 2, 2. When it's done, then start with the next one. Fill
But
that.
in this case, how would you find the next one? I mean, like here you picked one, right? Which are the highest frequency, 4. Then you pick the next highest frequency. So how would you do it without the priority queue?
So
Also in this, I think we need to loop again and again over the array.
You can sort the hash map by the frequency.
no, definitely. I mean, you need some way to actually keep these frequency, but you don't need to push
Got it,
back
got it.
again in the priority queue, update the priority queue. So anyhow, you need to find a way that so that you can find the element based on their frequency.
So it can be a nested loop within it. So it will be reduced until it becomes 0, and then it will go for the next key and the value, or until that key becomes 0, it will again go. So it will be a nested loop if we do not use any priority queue.
So I did not follow you. Could you please repeat again?
So it will be something like the key is 1 and the frequency is 4. Okay. Now, so you are iterating. So the first key is 1 and the value is 4. So what you can do is you will use the another loop, and you will try to reduce this value until it becomes 0. Okay. And then only you will go to next key and the value. So this way you can put those values. The poles, which can be something like 1 after skipping that value 1 and then skipping that value. So this way you can fill those value and it will become 0.
No, that is fine, but I believe the question is that how will you find these number based on the frequency at first place? So you need some way. Either you need to put in the map, or you need to actually use the priority queue.
Yeah.
So
Right?
we are sure on one thing, that we definitely need a map, right? Because we need to somehow store the frequency.
Yes. Either we need a map. Yeah, definitely. Initially, you have to put in a map, and then you need to find some way. One way is that you enumerate all and enumerate the map, and then find the element which has the highest frequency, right?
Sort based on the
Right,
value.
but you will based on the frequency,
Map,
right?
you cannot sort
So
based on the
you'll
value.
do it.
You will have to make the key, right?
Yeah, yeah.
So you
So
will
if
have to
we
reverse and create a new map based on the values.
2 times map or
Yeah, that's the implementation detail, that how you want to, whether you want to go with the create a map after that, after getting all the frequencies, or you want to put in the priority queue. But
I was
yeah,
trying to think that is there a way possible that we could do it without using the priority queue within the same time limits, or even better?
without priority queue.
I mean, how will you find that the frequency based on the frequency?
Exactly. So that is why I was asking you. So is this, are you thinking along the line of somewhere where we could do better than this without using the priority queue?
Hash map with the frequency if you get.
Yeah,
But again,
but then
I mean, I
guess
can,
you will have to every time after every insertion of that thing, you will have to
sort
go
it.
through each and every element and check with the frequency, and you have to keep updating it for highest and second highest frequent key.
Or
sorry?
each time you reduce the frequency by 1, you sort it again, the map with the frequency 2 times before sorting one hash map and again after.
Yeah.
But
So,
I don't know.
I mean, one way is that you can, after actually finding the frequency for all the elements, then you can enumerate and create another map based on the frequency.
Yeah, so
So
next time,
now
let's say, okay, go ahead.
what Gaurav did, that in the priority queue, is flip the value and key, So you can do that for that map.
Yes, sir.
Good.
So you are saying like
but there is no benefit. I mean, whether you go with the priority queue or you go with the map. Here if I'm saying the map, so that is a tree based map.
Okay.
Yes, sir. But then in that case, what you are saying, if we use the same in this in that map thing, but then you'll have to sort the map each and every time you iterate over that loop.
No, the tree map is sorted.
But that,
it's an ordered
yeah,
map. Right?
that's happening with the priority queue also, right?
Yeah.
Oh, you are using that map. Okay.
Login, it will be a login operation there. Yeah.
Yes, sir.
So, but instead of using a map, we could use an array, right? Because our array size is, the maximum size is just 10,000. So we can have a big array of 10,000 and we keep on updating that frequencies.
Or what we can do, I mean, what we can do, I mean, after finding these frequency, create a list and then sort that list based on the frequency only.
Yeah, that also works.
Yes, sir.
You have a pair with the list.
Yeah, and in that case, you don't need to, yeah. But I think in terms of Bigo, that will be same as priority queue.
Yeah.
But you sort the list only once, right? And you will
No,
always keep on looking.
Yeah, but Santosh, sorting is also n-log n and priority queue operation will be n-log n.
No, see, the priority queue, what happens, every iteration we have to pop out 2 elements and again update them and again push it back in the priority queue. So there is a log of n operations happening twice.
Yeah, in my case, I'm not pushing back.
You're not pushing back, but the priority queue will be, right?
No, in priority queue, so popping that element, that is a log n operation, right?
Right. And pushing also.
No. Popping is O1, right?
You're inserting next time.
Element, right?
Popping is not O1, it's log n.
Log n.
No, popping is O1. If it is a mini, like you can directly.
Minis and massive popping is O1, inserting is log n.
So when you remove that element, so what will happen?
Yeah, again EP5 will happen, right?
Yeah, that login will
login.
Because you'll have to push the last one.
This is your key, right? This is your priority queue, right?
My bad.
When you take this node, right?
You'll have to pick a candidate to come to the road, yeah.
So the top element will be the minimum element in the mean heap. So we can consult it in order of 1. It is always there. But once we need to pop it out, what they actually do is they put it at the back of the queue, reduce the length of the queue, size of the queue, and then percolate the because they are moving out. Sorry, how they do is they suppose the length is n. The n-1th element will be put into the top of the heap, the zeroth place, and they will let it percolate down. So that is where the log n is, so that the heap property is guaranteed for the next operation.
Yeah, so actually what will happen when you pop the element, so this element will go away and this element initially will take the place and then it actually push it back to the correct position.
Yes, sir.
Yeah,
that is EP5 operation.
Yeah.
Yeah, so in your case, Praveen, you're trying to eliminate all these things. I'm not saying it will be a huge optimization, but to some extent, surely there will be some optimizations. Yeah. So making a frequency of sorting of a list, that will be initially you'll do, right? It will be
initially that idea just came in my mind, but I think what just Gaurav explained that's a clean solution.
Yeah.
But
that is obviously the best solution for interview perspective. It will work perfectly fine.
But you are saying that root element is getting removed and we are like taking the last element to the top, but in the priority queue it's more like a queue. It's just that it is sorted, so you always remove that one element only from from the last. So why that will reshuffle again?
In priority, are you talking about the priority queue?
Yes.
So in priority queue, you always get it give you based on that whether it's a min or max. So the top will always give you based on that, right? Whatever type of priority queue. When you pop that element, so that is actually the root of that node, right? It will go away, and then it actually reshuffle and make sure that the root should be either the minimum or maximum element.
Excuse me, ma'am. I guess Sonal ma'am was speaking, right?
Yes, yes.
Yeah, ma'am. Actually, you said that in queue it would be sorted all along the way. It's not that case. Like for the foremost element ensures that that is the greatest out of all the elements, but in the next element, like in this case two, it ensures that it is greater. It is the greatest out of. Uh, um,
all the elements available.
No, not all the elements. It will be greatest, greatest from two. Its position is I into two plus one. Like it is basically in form of tree, in a form of a tree. It's like that, man. Like the topmost element ensures it is the greatest out of all the elements, but the second element, it's not like that. It's the second greatest. As soon as you pop out the first element, it reshuffles all the elements and find the greatest out of all of them. It's like that. It's not that as soon as
your tree could be like this. Let's say it's a max heap. So you have 32, then you may have here 5, and then here you may definitely will have smaller than 32, right? You may have
it is
here
smaller
31.
than 32, but it will be not it will be not smaller than 5.
And then here you may have 1.
Yeah, like in this case, it'll be for sure that under 5, all the elements will be smaller than 5.
Smaller than.
And
Here
under,
will definitely, here you can have 4,
it's like
you can
that.
have 3, and here you will have 1, and then here you may have 29.
Yes. It's not like that. The Sonal ma'am said that it will be sorted all along the way. It's not like that.
So that is called partial ordering. Actually, it will be more clear in the 32. If we can write on the left 31 and on the right 5, and we'll have to probably reduce that 31.
Priority queue is a linear data structure, right? I mean, like a regular queue with priorities.
It is a linear data structure, but it is represented in form of this tree. Then you get to understand this linear data structure thing. But then you have to understand this in this perspective, tree perspective.
So there is this difference between the priority queue and the binary search tree. So that is where binary search tree is called total ordering. So basically binary search tree, the root partitions the whole thing. So all the left one are smaller than him at the root, and all the right subtree is greater than the root. But the heap doesn't guarantee that. That's why it is not a fully sorted data structure.
Should I stop sharing?
Okay, thank you.
I think I know what it is.
Excuse me,
but that's you talk about like trend.
Let me show you one thing.
Type trend.
It will be more
Yeah.
visible?
Uday has a implementation similar to what Praveen was talking. It is of O of N implementation. He's shared in the chat. And this is what one was he was also talking about, right? Yeah.
Have this script to look at that, version when it added in. Yeah. But you can blame to see when it gets modified.
Is it visible by the way?
When you add it in, it's gonna be difficult. Because we branch it out from different branches, right? So even if you current branch and you trace it back to the time.
I think we do have a session coming on on coming weekend, right? Rainder is going to take the session on heaps, right,
Yeah.
Rainder?
Yes, yes, I'll be
Yeah.
taking
So
that.
that here,
We'll clear
I
that,
mean,
yeah.
he will cover in detail at that time.
Yes,
Yeah, I
yes.
think
These are all good discussion for me. I'm just taking note of this so that, and whoever shared the visualgo.net, thanks for that. I will bring that up. I was looking for that. Thank you.
yeah, I think Leon left. Oh, sorry. Yeah. Okay. Yeah. Okay. Good.
So shall we switch to next or?
Yes, yes.
Okay. So our last problem is like they have given some operators and operands. So you are supposed to get your target by using minimum number of operators. You'll be given a number and you'll be given a target, and using minimum number of operators you have to reach the target. And some rules are like your division. First, like negation is not allowed in here. If you see, just for a sec. Your negation is not allowed, and your division operator will return the rational number and no parenthesis anywhere. And this is normal, like order of operations, multiplication, division will happen before addition and subtraction. So for getting 19, they have used this way, and for 501, it's like this, and so on. Yeah, so how to approach?
So I guess I might have the approach, but as of now, my solution isn't approved.
Go ahead.
Yes, sir. So basically, what I've done, like we can use dynamic programming in this, and for like if we take this case of 19.
Can you start with your brute force solution first? If you have any, like,
I
what was
guess
your
brute force also would also include this thing, but it would be that normal recursion. It would be that normal recursion. That's it, I guess. That would be the brute force according to me.
But so you are saying that we'll always have a recursion. Other than that, we won't be able
Yeah,
to.
but it will include memorization.
No, that is fine. So it is again a top-down approach of DP, right? So
Yeah.
what I was also about to come to, okay, can we just discuss something on a high level about a brute force, how we could go about that? I know it's very difficult to even come up with that. So I thought maybe the group might have something we can discuss about it.
So one brute way, like since they're telling us to reach the target faster, so we should always use multiplication, right? Compared to all other operators, because it will help you to reach the target at a faster rate compared to addition, multiplication, or division.
So how
Actually, normal recursion, that is only, I guess, brute force. Like we are also finding out all the ways. We are only checking all the ways, and at the end, if we get the answer which is equal to the this key, like 3 in this case, if anyhow at the end we find out that the target is now equal to 3, like then we have gotten an answer. Like the normal recursion would be, I guess, the brute force, right?
Yeah, should be. You want to share like something? You want to explain?
So yeah, go ahead. But Shashank, you were saying like we can always multiply. What was that you said?
So what I was saying, like let's say 3 plus 3, if you do, it will make you to 6 only, right? But 3 cross 3, if you do, it will make you to 9. So that star operation, multiplication operation is, let's say your target is 10. So multiplication operator is helping you to reach closer to your target rather than using addition and subtraction. But next time if you use 3, it will be 27, but your target is 10 only. So then try to exhaust all multiplication if you could, and then use other operators.
Oh, So you are saying if your target in the first example is 19 and your
Yeah.
x value is 3, so you use multiplication operation in such a way that you will reach the target, the maximum of the target you can reach,
Closer
right?
to target. Yeah.
Closer
Yeah.
to the target. Maybe it will
Yeah.
be slightly lesser than that, but that will be the max value. And so that will be a value of whatever the multiplications of that x. So you will have n number of multiplication, right? In 19, it will be 3 into 3 into 3 into 3 into
No, you can't do
4
3 into
times.
3. 27 you will reach it otherwise.
3 into, okay.
So only 3 into 3, 19.
Mhm.
And again, then 3 into 3 they are doing.
Okay, but then why not just, because we also have a provision for division. So why don't we divide 19 by 3 always?
Oh, from target you are starting to reach to bottom.
Right, maybe the other way.
Yeah, that should. Then it works that way also. It's like from bottom, if you want to go, use multiplication. From top to down, then use division.
Oh, okay, okay.
Yeah. And then in minor operations, you can use plus minus to reach the exact value.
Yes, that is what
Kind
I've
of.
done. Yes, sir. That is what I'm thinking actually.
Yeah,
So
I mean,
Uh,
first
when
thing which
we start with, yeah, sorry.
so first thing which I could think of is that every step we have four choices. This plus, minus, division, and multiplication. So we kind of make four calls, choosing
Yeah.
each operator once, and then in the base case we kind of check if the expression we have computed so far gives me the target value, and then for that expression I count the number of operators.
So you are exhaustively generating all the possible paths, right? At in every step, and whichever is the shorter one, that you pick it.
Right, the first thing.
Yeah,
So
that's a recursion. Okay, go ahead.
you mentioned that, I mean, at each step we do have four option, but we also, if I do is correctly, we do also actually have another option to for the value also, right? So take an example for the first example. Looks like,
Okay.
I mean, initially it will do 3 into 3. Then if it will do the multiply by 3, that will not work. But if it will just do the plus 3, so that will not again going to work.
Yeah, it will be slower rate of reaching your target.
No, I think
No,
even the multiply by 3 also works, right?
But if you add the current value, whatever you actually evaluated so far, so looks like what's happening here. So 3 into 3. So you evaluated so far 9. Then it's doing 9 plus 9.
Yeah. Yeah, because you can't use next 3, right? It will cross your target.
Yeah, but
Yeah, excuse me.
you
Actually,
can then find the distance,
we can
right?
use next
27
3.
minus 19, you can find the distance. So then
Okay.
you will have the same number of operations. You will have 5. Even if you go more than 19, if you have 27, you will get the same operations.
Yeah, actually, the one who said that we can't use next 3, we can use it, but then we can use up to like n number of 3s, but then we have to somehow, by division, by
Subtraction, yeah.
subtracting, yeah, by subtraction, you'll have to come back to this 19 thing. It's like that. It's not like that. You have to only multiply, or you could use your operations till your answer is below this 19. It can.
No, I was just, I mean, I was not thinking of like coming backward. Like once you cross 19, then again you'll do some subtraction or something like that to reach target. I thought one way
No,
I'll go and reach the target.
yeah, you can see,
No,
like,
no.
even if you take the second example, right, 501. So if you multiply 5 3 times, it will be 125, right? Then you find the distance in 125 and 501 is too large. So multiply by 5, you have 625 and 501. The distance is less between 625 and 501. And then, yeah, then you go on subtracting. So that
Yeah,
way,
here crossing. Yeah.
yeah. So you can apply the same logic. Yeah, if applies, otherwise you then go for addition if you can't do that. Subtraction.
Subtraction, yeah. So, but it's like again what Ronnie was saying, like you do exhaustively all the possible operations and
Not
find
like
which
possible, but you start with the multiplication, as you said, right? That is the fastest way to reach the target.
the target. Yeah, that's true. Yeah.
Yeah, I mean,
Yeah, you have to start with
exhaustively
it.
you will have to evaluate and then find the minimum out of those, right?
Yes, yeah.
Actually,
Well,
what
this
you were
is all
saying that
theoretical. When implementation comes, then it will be difficult. So
Yeah,
someone go
challenging
ahead.
task.
yeah, that's why like I'm planning to have this with this top-down approach. In top-down approach, uh, you'll have this constraint of when you use this division thing. If it is divisible by 3, then you need to go further.
Division.
Like yeah, you can strike down one option, one case from there only.
Yeah.
Like when you if you take this case of 19, when you divide it by 3, it's not completely divisible, so you just strike down the entire case of this, and you have now 3 options only: multiplication, multiplication, addition, and subtraction. So it's like that every time, and every time you use this thing, if it is divisible by 3, you go ahead. If it is not, you just use 3 options, and at the same time you you could use this dynamic programming thing of memorization. If that value is already achieved, if it was already achieved earlier, that means it is uh, just coming back again in a loop. So
So
that's why
while returning from target to 1, you are not supposed to use multiplication also. You can avoid that because that is only
no,
going to increase
i
your
am i
value.
am returning from target to 3.
Your target to 3 you are returning. So why would you
Yeah.
multiply it by 3? Better don't multiply because that will only increase now. From 19, see you can't use division because 19 is not divisible by 3. But only one option is there, like subtraction you can use.
Nahin, how could you be so sure? Like, had it been the case of like after mm, you could say like you
21.
are saying that we shouldn't use this multiplication thing on the very first stage, right?
Yeah.
Yeah. So it could be this. It could be a case like if uh, if our answer was somehow manipulated in a way that that answer came by after moving forward, uh, moving
And then
ahead of this
backward.
19 thing, and then it came back using this
Okay.
manipulation of
That
some
could be one of the
division.
case.
Yeah.
Yeah, go forward and then backward.
Yeah.
Yeah. So then exhaustively is division also that can happen that case, right? Like
No.
might be you add
Yeah.
something and then
19 divisible by 3. 19 divisible by 3 is not possible, right?
yeah,
It's not an option. It means that 19 divisible by 3 would be 6 point something. So 6
something.
point something into 3 would have been the case, but that can't be the case, right?
Yeah. Okay, you can
And
share.
somehow we will reach our answer. And if this case, it's like I have read this thing in maths in my uh, first semester. They said that you can reach any number from by manipulation of a single number itself. So it will be the case. It's just that it'll take short number of steps, or like operations, or large number of operations. It's like that.
Okay. So you want to share like to your top down?
Actually, I have um, I guess I did this thing, but as of now, it's not approved. It's showing this error. Yeah.
So what is your recurrence equation here, right?
Yeah. What I did, what I've done, 1 second. Like from this case, this is the starting. I set up a counter. I set up a counter, and then after that, return solve this thing. So here I've used this this function in which I have taken 3 parameters, x, target, and counter. So if and at the same time I initialize a variable which is minimum, and then if that target, if that target it has been, if that has been already visited, we will just if it is not visited, then we'll just insert that in this unordered map thing. If it is already visited, then we just return int max. I'll explain you later like why I've used int max. Okay. Then if target is equal to, if it has come equal to x, then we have reached to our answer. Then we just return counter. As of now in this case, what I've done, if I take all the 3 possibilities of of subtraction, of addition, and of multiplication. I take minimum answer out of them. It can be the case like the answer this solution could be reached from multiple ways. So I take the minimum out of them, and in
So
this stage,
if the number is divisible by 3, then that you are taking as a special case, right?
yeah. If it is divisible by 3, then I include this thing also.
Okay.
So in the end, I return. Yeah.
Can you
But
explain
I
this
don't.
intermax part? Why are you taking this?
Yeah, intermax part, I am taking this because if you could say like if something like 26, if
Minimum thing.
26 is coming again and again, it's like it is then this thing, with this particular way, it's coming back in the loop. It's running on a loop.
Yeah, that is a loop will be caught.
Yeah, loop will be caught.
And because we are finding the minimum, so you have taken it.
Yeah, that's why. If this answer is in some way returns to this, the minimum out of them, which includes this int max, will be taken.
This is your brute force approach, right?
No, this is the dynamic optimized
I
approach.
think memoization you haven't used, right? Oh,
Where are you storing the answer?
oh, there he is doing.
Sorry, where?
I mean, where is he storing the answer? Like, he will
Yeah,
check before
I have the
finding.
same question.
You could say like I'm using this thing, I guess. This I'm not actually storing the answer. I'm just keeping a count of whether this answer is already visited or not.
Oh, that is only kind of memoization. No, I mean, next time you don't need to
Yeah,
avoid the loop you do. What for that?
yeah.
But it's just for avoiding the loop, right? I mean, let's say we have, let's say we have got the answer for 9 for any example, and then when you again reach 9, then you'll be again recomputing, right? Or are you inserting somewhere? I'm not able to find it. Sorry.
Yeah, I think for the top-down approach, you might
So
have to use a
basically, like
memoization,
nobody's
right?
Yeah. I
So
missed that part.
that is fine. You have not done.
Yeah, I
He's
missed
The
using,
that
I
part.
think,
map store is the map doing the memoization thing, like
I thought initially, but
Map is
he's
the
using
same.
it as a
I
visitor.
guess
Yeah,
you are
it's
right in that part. Like instead of this pull, I should use the answer itself and
right.
use this thing only.
so it is
Yeah.
passing every
No,
test
he has
score.
used
I mean,
No, he's
But
still working on it. Yeah.
I'll have to modify it further
line
to
12.
get the answer
So
of this.
he would insert that thing in a map, right?
Sorry, please come again.
So what is this map for them?
Yeah, it is basically now I haven't modified it yet. Like it'll keep a count of whether the thing it has been already visited, and at the same time, if it is already visited, we could get the answer, right? If it is already visited.
Yeah, if it is, that is memoization. If it is already visited.
Yeah. Yeah.
Okay, I think he's still working on the solution, but yeah, on a high level, yeah, things are it is pretty okay. Yeah. But do we have
I think
something?
he needs to store this min m somewhere, which is calculating, right?
Which is memoization, which is he needs to work for that.
Yeah. This min m basically is giving you the answer, and it needs to be stored somewhere that it
Yeah, you can
looks
use a
like
2D array.
somewhere.
Yes, ma'am.
Yeah.
Okay. So, do we have any other approach or maybe something workable one?
Okay. Well, like I haven't.
Or anyone wants to share their thoughts?
Somebody is using Digesta and all.
Yeah, there are many ways they are doing it. It's a very hard problem though.
Yeah.
Yes, Shashank, you have anything?
No, I don't have. Like I haven't done.
Okay.
I'll have to check it.
Yeah, I didn't work on this though. Yeah,
But I can share. I'm sharing. I don't know. Let's see.
Yeah.
All of us can come up with something. So he's just explaining here regarding the cost operations. So he's saying that if you have to represent a bigger number using a smaller factor, that would be much more costlier than using a bigger factor. So example he has taken a multiplied by x raised to the power I. If you do it using this, that means reducing the x by, you multiply x by one more x and then like this one, this way. This is same as the previous expression, right? This one. So this will be much more costlier compared to this operation a into x raised to the power I. So which indicates like kind of greedy concepts. Not that clear, like.
I think the multiplication point, which you were mentioning, Shashank.
Yeah.
That thing only I think is trying to convey. I'm also not really sure, but that's
Looks
what
like.
greedy.
Annual charge केलं त्यांनी मला.
I think we have to look. Let's look it and then somebody can come up. Let's look over this again, I think, or if anyone has.
Yeah, I think Gaurav's solution was pretty intuitive.
Intuitive, yeah, exactly. Yeah.
That is what I was thinking. To go for 4 cases and so these
And
questions are really overwhelming.
They are calculating the age cost in Digesta using all the. It's again beyond like. I have to look at it. Okay, let's check it. I think. So anyone has any apart from Gaurav?
No, actually, yeah. This was a tough problem to understand, but I think after going through what Gaurav was discussing and Shashank, you too, yeah, I think it is okay. At least to some extent, this is manageable. But if you look at the solution section, what these guys have actually described in the problem, it was, I think, the Alex guy who did that. In one case, he's using a very hard-coded value, say like I is greater than or equal to 39. And then that is what I really, got tripped up on that.
But that won't be a generic one, right?
One confusion I have in the Gaurav solution is like Gaurav, your solution is following BODMAS rule. Like it looks like from the example we are using BODMAS, right?
They have given instructions to use BODMAS.
What?
They have mentioned that you need to give preference to multiplication, division, and then addition and subtraction.
No, what I was saying is like 3 into 3 was 9, but after 9, they are adding 9 plus 9. They are not adding 9 plus 3.
Yeah, but that would be slower. No, 9 plus 3 would be 12 only, right? But 9 plus 9, if they add, I mean, again multiplication, that would help you to reach the target faster.
I think Sonal is talking about the rule that first the multiplication would be done and then the addition.
Yeah, it's not like that. It will be like you are first adding this 3 and then you are multiplying the 3. There is no case of BODMAS or I guess something like that.
No, if you see the rules, or rule number 3 says that the precedence of the operator. So multiplication has the precedence over the addition and subtraction.
Right.
Yeah, that's right.
And also, I don't think you need to get like 3 cross 3 plus 3 cross 3 operation, right? You can get 3 cross 3 cross 3. So you have to get 5 minimum operations. So maybe the explanation you got plus. In your while you're coding or in your program, you might get a subtraction instead of plus, like after multiplying going more than 19. So you can do that way as well. So it's not that it is you have to get the same expression.
Yeah, your expression may be different.
Yeah.
Yeah, one thing, can we bring this problem on this Sunday session so someone can pick it up? Because I think this is a candidate for more discussions on a good approach, which we can get very easily in an interview. Maybe someone will help or us there, right?
Yes, sir.
What do you think, Shashank, Praveen?
Yeah, it will be better. Let's make a
Yes,
list.
we
Like,
can.
I think
Yeah.
throughout the week, let's make a list, like whichever problem we are not able, that would be discussed on the weekends.
Yeah.
Yeah,
This
or
one
after 2 days. Yeah.
After 2 days, yeah. Because there are many people over there in that session, right? So someone will surely help us.
Exactly. So let somebody keep a track of, like, just mark this number 964.
Yeah, 964, and then we have that monotonic Q1, which had those max subarray, which had minus negative numbers also. Yeah, that one, and yesterday's that matrix problem. So these 3 we can actually bring it up.
Let's keep a track of that.
Yeah, at least 3 of them.
Which one is max array? Which one was that? Sorry, I did not catch.
So the max array, it had an array of integers, but they were not negative. What you say? Not only positive, they were negative as well as 0. And then you have to find a max array with the minimum length.
I'll go through it. I'll go through.
Yeah.
Okay.
So that's a very interesting problem, because normally the max array you can easily solve it using a 2-pointer approach if it is all positive numbers. But I think Henny also discussing at that time, right? So if we have additional 0 or negative numbers, then you have to handle it differently. You can't use the 2-pointer approach; it fails.
Okay.
Yeah, that's a trick.
So where are you noting? Like, you are keeping track?
I just know about it, so I can bring those, at least these 3 problems. And
Yeah,
then,
so that otherwise we'll forget. Like, we have.
Yeah, at least for this week's session, I have all that.
Okay,
But from if they don't, it doesn't happen this Sunday, because I think Rajendra is doing this Sunday session, right? So we'll have some topic on this Sunday. But if that doesn't happen, if it happens on the next Sunday, then I'll keep a track of all these. Okay.
Exactly.
One session is like that a virtual data structure in Algo. What is that? Like in the announcements, it is there. I'm not clear about that.
So virtual means the online.
Okay, so it is